Resistors in series and parallels. Dear students, in this video I'll be teaching you resistors in series. Resistors in series means you're connecting resistor one after another. You can connect any number of resistors one after another is known as resistance in series. When two or more resistors are connected end to end, they are said to be in series. The resistor could be simple resistor or a bulb or heating elements or any other devices. The three resistors R1, R2 and R3 are connected in series. The amount of charge passing through the resistor R1, R2 and R3 are called total resistance. So you have to find the sum of R1, R2 and R3. Dear students, you can see a complete closed circuit in which the current I flow from positive terminal to negative terminal. V is the potential difference, R1, R2 and R3 are the resistance. They are connected in parallel. That means the one after another resistance. For a complete circuit, it is not required that you have to connect more resistance. You can also connect single resistance as shown in this slide. You can see the current flow from positive terminal to negative terminal. V is the potential difference and there is only one RS which is called as equivalent resistance. So single resistance also you can connect in a closed circuit. Dear students, in this slide you can see how a resistor will look like. I have connected 3 resistor 1 kilo ohm, 2 kilo ohm and 3 kilo ohm in series with the battery as shown in this slide. So this circuit is complete and current pass through this. Due to this reason, the current passing through all the 3 resistors is same as the resistors are connected in series. According to Ohm's law, if same current passes through the different resistor of different values, then the potential difference across each resistor must be different. Let V1, V2 and V3 be the potential difference voltage across each of the resistance R1, R2 and R3 respectively. Then we can write V equal to IRV. Total resistance R is nothing but R1 plus R2 plus R3 and I is equal to V by R. Here I is same for all the 3 resistance. V is nothing but V1 plus V2 plus V3, whereas V1 is equal to 1 IR1 plus IR2 plus IR3. V is equal to, we have taken I common, R1 plus R2 plus R3. Whereas R is equal to R1 plus R2 plus R3. When several resistors are connected in series, the total or equivalent resistance is sum of individual resistance. So remember, our formula to find potential difference is IR, whereas R is equal to R1 plus R2 plus R3, and if you want to find the potential difference, V is nothing but V1 plus V2 plus V3. And current I is equal to V by R. Here, in this slide, the numerical is solved, which will help you to understand better. Calculate the equivalent resistance for circuit which is connected to 24 volt battery and also find the potential difference across 4 ohm and 6 ohm resistance in the circuit. So here is a solution for you. Just add all the resistance, that is 4 ohm plus 6 ohm is equal to 10 ohm. This is a total resistance. Current is equal to V by R. V is given as 24. So 24 by 10 is 2.4 ampere. SI unit of current is ampere. So voltage across each resistor is equal to V is equal to I into R1. V is nothing but the current we got it as 2.4 ampere into 4 ohm. It is 9.6 volt at R1 and at R2 it is 2.4 into 6 ohm 14.4 volt. So individually we can calculate the potential difference if current and resistance is known. So it's very easy. I'm sure you'll be able to solve all the numerical based on series formula. Now I'm recapping the formula V is equal to V1 plus V2 plus V3, where V is a potential difference. We know that V is equal to IR. Since we have three resistance which is connected in series, so sum of resistance is equal to capital R. So R1 plus R2 plus R3. R1 resistor, so I into R1. At R2 it is I into R2, and at R3 it is I into R3. We can take out the I common, so R1 plus R2 plus R3. R1 plus R2 plus R3 is equal to the equivalent resistor R. So you can calculate potential difference is equal to IR, or you can also calculate potential difference across each resistors. Circuit diagram of resistor in series is shown in this slide. So dear students, kindly remember, in series you have to connect one after another, that is R1 plus R2 plus R3 across the potential difference V as shown in figure. Dear students, in next video I'll be teaching you resistors connected in parallel.